Hey guys, this is the third video in which we will be discussing some of the problems from the Lorentz transformation and velocity addition theorem. Question 1. A spaceship is measured to be 120 meters long and 20 meters in diameter while at rest respective to the observer. If the spaceship moves at speed of 0.99 c with respect to the observer, what will be the dimensions of the spaceship according to the observer? Pause the video now if you want to try this question on your own. This is a simple and straightforward question in which we only have to apply the length contraction formula. We need to remember that only the dimension parallel to the motion of the spaceship will change. So the diameter of the spaceship will not change. The length will be equal to L upon root of 1 minus v square by c square, which is equal to 120 upon root of 1 minus 0.99 squared, which comes out to be around 17 meters. In this question, the length of the object was parallel to its direction of motion. What happens if the object is inclined? Question number 2. An object 100 meters long has its length inclined at an angle of 30 degrees with respect to the horizontal. It moves with a velocity of 0.5 c in the direction of the horizontal with respect to an observer on moon. A. What is the relativistic length of the object? And B. What is the angle between length of the object and the horizontal according to the observer? Pause the video now if you want to try the question on your own. In this question, the length of the rod is inclined to the direction of the motion. Now we have to resolve the x and y components of the length. Only Lx will change and Ly remains as it is. Since Lx changes, the angle according to the observer will also be different. Now, L dash equals 100 meters. It will be resolved into two components. L dash x equals 100 cos 30 because the angle given is 30 degrees, and Ly equals 100 sine 30. Now L dash x, L dash y, L dash x equals 100 cos 30, which is equal to 100 root 3 by 2. Now Lx equals 100 root 3 by 2 into root of 1 minus v square by c square. This, when we solve for v, we plug in the value for v, we get 100 root 3 by 2 into root of we have 0.5 c, so 1 minus 0.25, which will give us around 75 meters. Now Ly will remain equal to L dash y, which is equal to 100 sine 30 degree, which is equal to 50 meters. Now angle theta will be equal to tan inverse Ly by Lx, where theta is the angle between the horizontal and the rod according to the observer, which is equal to tan inverse 50 upon 75, which gives us around 33.69 degrees. Now if we look at it, we have our rod here and it gives us 30 degrees. Now if we shorten the x component of the rod and keep the y component as it is, that is, if the height is the same and the length becomes shorter, the angle increases. So this answer makes total sense. Moving on to question 3. Two spaceships A and B are moving towards each other. According to an observer on Earth, the spaceship A is 100 meters long and moving with a speed of 0.75 c, while spaceship B is 80 meters long and moving with a speed of 0.85 c. Part A. What will be the length and speed of spaceship B with respect to crew in spaceship A? And B. What will be the length and speed of spaceship A with respect to crew in spaceship B? Pause the video now if you want to try the question on your own. Here first we need to find out the velocity of A with respect to B and velocity of B with respect to A. We do that by velocity addition formula. Then we can find the apparent length by length contraction formula. In this question there are three frames: the S frame, the spaceship A and spaceship B. But we can convert it into two frames and one object problem by taking frame A as S dash frame and B as object for part A and B as S dash frame and A as the object for part B. So for the first part we take S dash frame as A and we solve for that. So Ux equals to 0.85 c minus, because it's traveling in the negative x-axis, and v equals 0.75 c. So u dash x using Lorentz transformation formula is equal to ux minus v upon 1 minus ux into v by c square, which is equal to minus 0.85 minus 0.75, and we take c common, divided by 1 minus 0.85 c into 0.75 c upon c square, which is equal to 0.977 c. Oh, I forgot a negative sign because it's traveling in the negative direction, and so u dash x equals minus 0.977 c, and this is the first part. And now length of the spaceship B, LB dash, equals to LB root of 1 minus u dash x squared upon c square, which is equal to 80 root of 1 minus 0.977 c squared upon c squared, which is equal to 80 into 0.2132, which is equal to 17.06 meters. And so you see the length of the object becomes very small as our speed approaches the speed of light. Now for the B part, we will take the frame of spaceship B to be S double dash frame so that we don't get confused later on. And okay, wait, let me add UXB over here, VA and U dash XB and length of B. And here UXA equals to 0.75 C, VB equals 0.85 C. Now U dash A, okay, let's say double dash, equals to UXA minus VB upon VB is minus 0.85 C upon 1 minus uxa into vb by c square, which is equal to 0.75 c plus 0.85 c upon 1 minus 0.75 c into minus 0.85 c upon c squared, which is equal to obviously 0.977 c. Now we use the length contraction formula for our spaceship A, and length of A equals LA root of 1 minus u double dash A upon C u double dash A square upon C square, which is equal to 100 root of 1 minus 0.977 C squared upon C squared, which is equal to 100 into 0.2132, which is equal to 21.32 meters. Now this ends the third question. Moving on to the fourth question, a spaceship is moving with a velocity of 0.7 c with respect to an observer on Earth. The spaceship ejects particles with velocity of 0.99 c with respect to itself in the direction perpendicular to its motion. What will the velocity of the particles be according to the observer? Pause the video now if you want to solve the question on your own. Here we have two reference frames S and S dash and particle A moving in the y-axis at a velocity of 0.99 c, that's our uy dash, and our S dash frame, that is the spaceship, is moving with a velocity v, that is 0.7 c. So v equals 0.7 c, uy dash equals 0.99 c. According to the S frame, we will have two velocities ux and uy, and then we'll have to resolve to get the velocity of the particle in the S frame. So according to the formula, ux equals ux dash minus plus v, because we are using the inverse Lorentz transformation, upon 1 plus ux dash into v by c square. Since there is no velocity in the in the x dash axis, so ux dash equals 0. Now this will be equal to 0.7 c upon 1 plus 0, which is equal to 0.7 c, and uy equals to uy dash upon gamma 1 plus ux dash into v upon c square, which is equal to 0.99 c root of 1 minus 0.7 c square upon c square, we'll put the brackets here, upon 1 plus 0, which is equal to 0.99 c root of 0.51, which is equal to 0.707 c. So u is the resultant of ux and uy, which is equal to ux square plus uy square, which is equal to root of 0.7 c square plus 0.707 c squared, okay, here, which is equal to 0.9949 C, approximately equal to 0.995 C. Sometimes, to check whether I am using the correct formula, I plug in c as the velocity of the object. Since I know that velocity of light does not change in no matter what initial reference frame we are taking, I should get back c in the answer here in the velocity u. The next question will explain what I mean. Question number 5. A spaceship is moving with a velocity of 0.7 c with respect to an observer on Earth. The spaceship ejects photons in the direction perpendicular to its motion. What will the velocity of photons be according to the observer? I urge you to pause the video here and solve the question on your own. Here you can see that the only difference between the fourth and the fifth question is the velocity of the object. Here we have a photon whose velocity is c, and in that question the velocity was 0.99 c. So v equals 0.7 c, uy dash equals c, ux dash equals to 0. Now we need to find ux and uy and resolve the vectors just like in the previous question. So ux equals to ux dash plus v upon 1 plus ux dash into v by c square equals to 0.7 c upon 1 plus 0, which is equal to 0.7 c. Uy equals to uy dash upon gamma into 1 plus ux dash into v by c square, which is equal to 0.9. In this question we have c into root of 1 plus 0.7 c by c whole square upon 1 plus 0, which is equal to c into root of 0.51, which is equal to 0.7141 c. Now u equals root of ux squared plus uy squared, which is equal to root of 0.7 c square plus 0.7141 c square. Okay, let's add them in the brackets to avoid confusion, which is equal to 0.99969 c. Now we are getting an approximate result because we have approximated the value of uy, which is 0.7141 c. Now if we were to add root of 0.51 c, we would get exact value of c. So here are the 5 examples for the topics we have already discussed before in the previous videos. Now in the next video we will move on to laws of simultaneity.